Good morning. So I think it's time to start. It's a quarter to 12. So my name is Louis Latour. I'm working as a DevOps for FHIR. And it's my pleasure to introduce Darren Devitt, who will explain why we need a proxy and why we need to build a proxy in front of a server.
Thanks. So extending FHIR, why you need to build a proxy. So I'm Darren Devitt. I'm a FHIR advisor to medtech companies. I write about FHIR on my website and on LinkedIn, and I created the Vanya FHIR Viewer, which some of you might be familiar with. So why might you need to build a proxy? Commercial FHIR servers are not production ready. Now, what do I mean by production ready? You could go on to Azure or AWS right now and spin up a brand new FHIR server in about 10 minutes. On Google Cloud or on AWS, we're missing something. Okay, what I was saying was, on Google Cloud or on AWS, you can check a checkbox and pre-populate that brand new server with test data from Cynthia. That'll generally add about another 5 minutes to the setup time. So that means that after 15 minutes, your developers could start writing code and posting requests to the FHIR server. They could start writing queries in Postman and consuming data from the FHIR server.
We'd rather wait or then get a new cable instead of having this technical problem.
Okay, let's start again.
Not just yet. It will work now, but
I think you should maybe talk and
Keep going.
because otherwise you will have to show.
Okay. All right, well, I'll carry on without the slides. So these particular servers that you can spin up in about 10, 15 minutes from Azure, AWS, and so on, they're ready to use, but they're not ready to receive live data or live clinical data or live patient data. They need to be extended and enhanced, sometimes in considerable ways, depending on the use case. Now, one way to do this is to build what I'm calling a FHIR proxy. Now, what do I mean by a proxy? A wrapper essentially in front of and around your FHIR server. And this wrapper would intercept requests on the way into your FHIR server and intercept the responses as it flows out of the FHIR server. So essentially, it would allow you to do things with the request body before it reaches the server and do things with the response body before it reaches the consumer. Now, usually this proxy or wrapper layer would sit between your API gateway and the FHIR server itself. If you don't have an API gateway, then the proxy would essentially become your FHIR endpoint. So why might you want to intercept data flowing into your FHIR server? Now, a number of reasons that I'll go through, but there would be many custom reasons unique to your use case as well or to your business. So examples might be applying custom business validation before it reaches the FHIR server, making changes to the data, so making changes to the request body, the bundle or the resource before it reaches the FHIR server. You might want to extend the FHIR server by building custom operations. And one place to put this would be inside your proxy or wrapper layer. And if you have a multi-tenancy requirement, your multi-tenancy approach might involve channeling a request to different FHIR servers. And again, this is a place to do that. You might also want to cache certain queries coming from certain consumers and use them later. So let's look at the custom business validation in a bit more detail. So most FHIR servers, pretty much all commercial FHIR servers, will validate incoming bundles and resources against the FHIR spec itself. And most, again, will validate profiles as long as the profile or implementation guide is correctly installed in the FHIR server. But quite often there would be specific validation that is unique to a particular business case or use case. So examples might be, say you have a create request coming in for a new patient. You might want to do something with that before it reaches the FHIR server, possibly to prevent duplicates to patient resources. And to do that, you might do something like when you intercept the request body, you might make calls into the FHIR server yourself to check for duplicates. You might make a call to a patient match operation that you had built yourself. You might even make calls to an external service that manages patients for you to see if it's a duplicate. And if it turned out to be a duplicate, you might want to return an operation outcome in the bundle and not allow the request into the FHIR server at all. A similar example might be a medication request coming in. You might want to make a similar call to a medication service to see if you have that particular medication available or not. And if you don't, return an operation outcome instead of allowing the medication request into the FHIR server. So you might also want to change the request body again before it reaches the server. Examples of why you might want to do this would be to add specific security labels to particular resources before they're allowed into the server. You may want to tag AI-generated data in some kind of special way. So quite often AI-generated data, as most data coming in from data providers, will contain a provenance resource. You may want to do something a little more than that. You might want to add a security label that says it's AI-generated, a tag. You might even want to create a whole new provenance resource that identifies it as AI-generated in some specific way that you want to capture. And you could then inject that provenance resource into the transaction bundle and allow the bundle on into the FHIR server. So other examples you may want to tag data for might be, depending on the data provider, you may want to clean up certain data or certain resources at some point in the future. So you tag the data to that effect, possibly even using security labels again, possibly using tags. And you may want to tag data, sensitive data coming in from particular sources again. You might also want to extend the FHIR server's functionality by way of custom operations. Now, I sent out a survey to a number of organizations about 6 months ago, and I asked them if they had built custom operations. 36% said yes, they had, which is quite a high number considering there's a lot of work to do in building a custom operation. Now, one place you can put a custom operation would be inside this proxy or wrapper layer. There are different ways of doing it, but this would be one way of doing it. And examples of operations you might want to build would be value set terminology operations if your particular FHIR server provider does not support those operations. Even simple operations like value set expand would not be supported by all FHIR servers. You might want to implement your own patient match operation, or you might have one or many unique operations that are unique to your particular business and use case. So channeling requests to different FHIR servers. Now, there are many different approaches you could take to multi-tenancy. One particular approach I've encountered a number of times is to have different individual FHIR servers per tenant. So then a request can come in, you intercept the request before it reaches a FHIR server. You identify the tenant, possibly based on a request header, possibly a token or something else like that. And based on the tenant, you channel the request to one specific FHIR server. So the data has gone into your FHIR server, you've allowed the transaction bundle on in, possibly changed with extra security labels and so on. Why might you want to intercept the bundle coming out? Again, lots of reasons here. You might want to implement attribute level access control, sometimes called element level access control. You may want to anonymize some of the data depending on who the consumer is. You might want to update resources after the request has run. You might want to cache a particular query coming in from a particular data provider, or you might want to trigger custom events and notifications. So let's look at those in a little more detail. So attribute-based access control. That same survey I mentioned to you a few minutes ago, I asked this question as well. Have you built any version of attribute or element level access control? And 38% of the people who responded said they had, which again was quite surprising because implementing this particular feature in FHIR is a very, very big piece of work. And when you intercept the bundle on the way out, this is a good place to do that because you know who the consumer of the data is. You have the bundle right there about to go to that consumer. So at this point, you can run whatever rules engine you might have built based on who the consumer is. And you may decide to remove certain elements or remove certain attributes of elements from those resources.
Can I stop you for 1 second? Is it okay if we put the laptop in the back of the room and then you use the clicker? Because then we can actually get the slides on the screen. Yeah?
Yeah.
Perfect. Thank you so much.
Attribute-based access control is one of the key reasons why people build a version of the proxy layer to begin with, or a wrapper layer. So similar to attribute-based access control, you may want to anonymize certain elements before the bundle reaches the consumer. So an example here would be not all consumers are allowed to see all data. So you may have a number of different
Perfect. Thank you so much.
So as I was saying, not all consumers of data are allowed to see all data. So some consumers may be allowed to see most data. Hospitals, doctors, and so on would have certain rules. But there may be a particular consumer who is not allowed to see any PII data. They might be displaying, say, aggregated metrics or data that contains semi-anonymized observations. So in this case, when you intercept the bundle on the way out, you have the entire bundle. You can decide again to run some kind of anonymization engine, remove certain resources, remove certain elements from resources, or anonymize certain elements. Examples might be dates of birth, genders, names, addresses, that kind of thing. Even things like display names attached to resource reference links that show the patient name. And again, you may also want to include an operation outcome in the bundle before it goes back to the consumer, telling them what you've done. So we've applied a certain anonymization rules to this particular data set because of reasons X, Y, and Z, and so on. You might want to update resources after the request has run. So an example here would be your FHIR server provider might not automate the creation of audit event resources. And if they don't, you have to do this yourself. You have to implement this particular feature and create an audit event yourself. And by intercepting the response on the way out, you're then in a perfect position to do this. You know who the data provider was, you know exactly what the incoming request was, and you know exactly what the response going out was, all the resources in the bundle. So you have all the information you need to update an audit event resource. You might also want to update a provenance resource that might have come in as part of the initial request. So provenances, as most of us probably know, will contain reference links to any resource created or updated as part of a transaction in the provenance target element. But it would not normally contain the version number of that particular resource because that won't be known at the time the data provider created the provenance. But when the request has run and you're looking at the bundle coming out, you have enough information there to go back in and update the provenance and attach the version number if that's a particular use case or something you require. You might want to trigger custom events and notifications. So you may want to notify whoever's listening via message queues or event brokers. So a create comes in for a particular resource, an update comes in, they're notified of that. You may want to implement a version of FHIR subscriptions if it is not supported by your server provider. So as some of you may know, not all FHIR server providers support FHIR subscriptions. And if your consumers are expecting this as a particular feature, or they rely on being notified via FHIR subscriptions, you might have to implement this yourself by way of some subscription service. And at this point then, when you're intercepting the response on the way out, you could then make a call to the subscription service so it can update whoever's listening. So to conclude, a proxy opens up your server for customization. It means you're no longer dependent on your FHIR server provider to implement small or complex features that you may require. You pretty much have ownership around your FHIR server. You can add whatever you need to it at any point. So it answers a lot of the architectural questions around FHIR servers. How do we do this? How do we do the other? So my experience has been that the primary reasons companies or organizations build a version of a proxy layer like this would be either as a way to implement custom operations or as a way to implement attribute-based access control. And once they build it, they can then add various pieces or functionality to it over time. So if anyone's interested in an example, Microsoft have produced an open source project that they maintain for the past few years. They call it the Azure FHIR Toolkit, and it essentially implements a version of what I just talked about here. It's a very customizable project. It targets Microsoft Azure FHIR servers, but it can be adapted quite easily to other server providers as well. Thanks for your time.
So I have to say congratulations, despite all the problem, you stick on time, so perfect.
Well, the next speech will go better because now I've been through this.
So now we have 5 minutes for the question. So if anyone has a question for Darren. Yes.
Hello. Can I stand up or? So I have a few questions. So we're building a proxy right now in our company, and it's for reback, not ABAC, but for access control from instance C2. And we're looking also maybe to use it for searching capabilities. So maybe to export our data in a search engine to be a better search. So question is about, do you think it's a good idea to use that proxy for searching on our data?
For searching through your FHIR server, as in via GET requests and so on?
So instead of getting to the server directly, because we use Azure Health Services, which the search is has not all the capabilities for geo-localization and things like that. So we want to maybe export the data with subscription into a search engine like OpenSearch or Elasticsearch, and then use a proxy to search against that instead of searching against the server.
Oh, so you're not searching directly against the FHIR server, you're searching somewhere else.
We're looking to do that thing.
Yes.
So I want to have your insight about it.
Yeah, I would say most definitely, as long as the consumer is aware of what's happening, but you could probably let them know what's happening via an operation outcome as the data flows back out.
Okay.
But yeah.
All right. Great. Thanks.
Yes.
Yeah, I also put it in Hoover, but yeah, okay. So I have the mic now, so I might as well ask it now. So we're also building a proxy, and one of the things that the proxy is doing is rewriting URLs, right? So if you have a proxy and then the endpoint of the FHIR service, something else that has a different URL than the proxy, so you have to rewrite stuff. For instance, the full URL in the bundle, but also references. Do you have any best practices concerning those rewrites?
I wouldn't say best practices. It can be, depending on the FHIR server provider you're using, it can be a bit more tricky than that. I know Microsoft Azure have a way of setting the URL as part of the request. Mm-hmm. So that's one way of doing it. I've encountered this before where we've done the same kind of thing. And it's important to know what the end URL obviously is. It might not be the proxy endpoint. It could be, say, an API gateway endpoint, which exists further up. So you'd have to know in advance what to set that to.
Okay, but it's not more to it than this.
In terms of rewriting the strings, no, you're simply replacing one string with another.
Yeah. Okay.
Yeah.
Yeah. Thanks. No gotchas. That's
no, not
just
that
checking.
I've encountered now.
Thank you, Darren. Mikael Rinnatmäki, SensorFriend Finland. A word of caution for anybody building these proxies. We have the experience that when we post some data to a FHIR server, let's say 200,000 observations, we can do that with batches quite effectively, data running through in a couple of seconds. And then somebody introduces a proxy before that FHIR server takes in the bundle and then feeds all of the observations individually to the actual FHIR server. And that slows down the process 10 or 100 times, and suddenly it takes half an hour to upload those data. So do keep these things in mind when you're implementing the proxies. So bundle processing, really efficient way of storing data. We like that.
Definitely a trade-off, yeah.
Yeah, not necessarily even a trade-off. I would say more of a implementation practice. So don't process each observation individually and then store it to the FHIR server. Rather treat it as a bundle, and then it also goes to the FHIR server faster. Thanks.
Hi, you talked about filtering data on the way back to the user or to the client. Do you imagine a point where it becomes not a very good or not an imperformant idea to maybe do a big search, have a big bundle, and then filter it down to like 3 or 4 parameters? And what would be your solution in this case to implement something like that when you're filtering a lot of data out of the result? Yeah,
I would say it depends on, the volume of data. Different approaches you could take to that. I mean, Microsoft, again, have produced an open source project that is used for anonymizing bundles of data. So if one of the use cases was not ABAC, if you were, say, anonymizing data and taking out a lot of data or anonymizing elements in data, looking at that project could be useful. They use FHIR path expressions that are configurable to basically instruct the bundle as to what to do with certain elements and so on and attributes. So that's a useful way of doing it.
So I will go for a last question, and we have 1 more minute.
Hi, everybody. Hi, Darren. Isaac Vetter, Epic. First, I wanted to say thank you for the session and for all of your prolific educational content online. I think that's appreciated and really good stuff. You reference 38% of organizations do element level filtering, I think. Could you just explain a little bit, like, what is organizations? Like, what do you mean by that term?
When I say
how to gather that data?
Yeah, when I say organizations, I'm referring to an organization or a business that uses a FHIR server. So one of the commercial FHIR servers that you might build a proxy like this around. So it could be a business, it could be a company, it could be an organization, whoever's basically using these FHIR servers. Does that help, or is that too vague?
Too vague. And then where'd you get that number?
Oh, okay, right, I understand now. Yeah, it was a survey I ran about 6 months ago. The number of respondents was quite low, it was about 75. So I asked them about 15 different questions. This particular question was one of them. So they would all be generally technical people who were involved in FHIR projects. Some of them would be private business, some of them would be maybe data providers and so on. So cross-section.
Okay, so I think it's time. Thank you for attending. Maybe a reminder, you can fill the feedback for the session. Also for the question, if you still have some question or you ask question afterwards, so you want more, don't hesitate to put on Woover so you can follow up on that. So thank you.